Hello students, the purpose of this video is to help prepare you for your quiz 11. So the first thing I want to point out is that this quiz is due in final form on Friday, April 23rd. If you want feedback on the quiz before the final due date, then you need to get the quiz to me before the end of the day, Monday, April 19th. That is the Monday after spring break, so you can work on it before spring break, over spring break if you're just totally nuts, and you'll get 1 day to work on it when we get back from spring break as well, to give you enough time to finish it for feedback. So let's just look at these questions quickly, and I'll point a few things out about them that are important to keep in mind while you're working through them. In number 1, you are looking at a function g of x, and please notice that the domain of g of x has been restricted. That has something to do with whether the function is one-to-one. So these two concepts are tied together, and it will affect your explanation of whether the function is one-to-one or not. When you go to, I kind of skipped over part A, but when you're looking at g of x and converting it into g inverse of x, you're going to be using a multi-step process where you switch x values and y values, and after you've switched your x values and y values, then you solve for y, and that will give you your inverse. You're going to graph g of x and g inverse of x on the same graph, so I do want to remind you that inverses are symmetrical. They are symmetrical to each other, but they are not symmetrical over the x-axis or the y-axis. They are symmetrical over this diagonal line with a slope of 1. So the two images you end up drawing should be symmetrical over this line. The domain and range of g and g inverse also share a relationship. So if you have g of x's domain and range, those should be the reverse of g inverse's domain and range. In other words, the domain of g is the same as the range of its inverse, and the range of g is the same as the domain of its inverse. So you can use those facts to find the domain and range of both functions. Okay, I just mentioned sort of the solution technique for number 2. There are two different ways to think about inverses. We could think about inverses visually as a reflection over this line, or you could think about inverses as points x comma y. We're going to call these, actually I'll call this a comma b. In the inverse, you flip the point around and it becomes b comma a. So two different ways to approach these problems. You can either figure out what the point currently is. For instance, this is 5, that's a terrible example. For instance, this point here, another terrible example. Here's one. Okay, so this point here is -3 comma -5. If we were to reflect this into its inverse, it would become the point -5 comma -3. So we would need to put the point -5, -3 on our new graph. So this point would become that point, so to speak. And you can do that with all the points in this picture. Okay, just answered that part. In part B, where we ask you to explain the process you used, you're either going to be telling me about the reflection across of this axis of symmetry, or you're going to talk about the method you used where you take your point, you reverse the x and the y value, and that's how you get your new point. So I just want you to explain there which of those processes you used. And then finally, part C, we just discussed this. If you know the domain and the range of f, you can easily find the domain and the range of f inverse because they're just reversed, or vice versa. If you know the domain and range of f inverse, you can easily find the domain and range of f because it's reversed. For number 3, we want to use the inverse function property to determine whether each pair of functions are inverses. So this has to do with composition. There is a bit of a formula you need to know. What we're going to do is we're going to find f of f inverse of x. And what should happen if these are inverses of each other is they should essentially undo each other, and you should just end up with x. So for instance, I'm actually going to do an example here. If we start with this problem, f of x equals x plus 2, and g of x equals x minus 2. If I want to know whether these two things are inverses, then we can take f of g of x, and if this is equal to x, then they're inverses. So let's test it. We will take f of blank, which gives us blank plus 2. And inside that blank, I'm going to put g of x. So g of x, which is x minus 2. And then if we simplify this, we get x minus 2 plus 2, which is just x. So f of g of x is equal to x. That makes f and g inverses. So basically what it means is, first, f tells you to take x and add 2. Then g of x tells you to take x and subtract 2. So these two functions essentially undo each other. You start with x, you add 2, and then you subtract 2. And so they undo each other, and you just end up with x. So this just goes to show you how taking a composition of two inverses should cancel out and just give you x. And that's what this question is asking you to do. The inverse function property. So I'm going to actually write out the inverse function property for you. The inverse function property says if f and g are inverses, then f of g of x is equal to x, and g of f of x is equal to x. That's the property that we're going to try to show for A and for B. In number 4, we are starting from a parent function. I don't know why it says starting with a base graph. We've always, all year long, we've called these parent functions. So we're going to start with our parent graph, and our parent graph will be f of x equals e to the x. And then use transformations. So we're going to be flipping, we're going to be flipping again, we're going to be shifting, we're going to be shifting with transformations to go from our parent function to our final transformed graph. So this grid here, this coordinate plane, is going to have two pictures on it. It's going to have your parent function, and it's going to have your final transformed graph. Then when it asks for the domain and the range of the function, we're referring specifically to g of x, so the final transformed graph. We want the domain and range of that function. All right, number 5 is basically a carbon copy of number 4, except in number 5, instead of dealing with an exponential, we're dealing with a natural log. But those two things are very similar because they're inverses of each other. We're going to be doing basically the same thing. We're going to be starting with the parent function, and this same graph is going to have the parent function and the final transformed function. And then they ask the domain and range, etc. So we're starting from the parent function of natural log of x. And from there, we're going to be shifting, etc., using transformations. All right, so hopefully that's enough to get you started on these quiz questions. I am more than happy to help you as you're completing this quiz over the next few days. And I also encourage you to submit your quiz ahead of the feedback deadline. That way I can help you even more before you have to turn your final version of your quiz in. Good luck, and let me know if you have any questions.